Okay, the position vectors of the points A and B relative to a fixed origin O are given by the following there, right? A is 5i plus 12j, B is 7i plus 13j. So remember, the term position vectors, okay, always describes where the points are relative, yeah, as it says here, relative to the origin, okay? So it's telling you how to get there, like coordinates, essentially. So in part one then, it says, find, okay, the modulus, right, of A. So when we see that modulus symbol there, right, with bars around A, basically they want the size of A, right? How big is A? Okay, how long it is. So sometimes it's good to actually draw a diagram, all right, and to see exactly how this process works, right? And you just got to remember, okay, you know, for A, for instance, here is 5i plus 12j. Well, that means you're going across 5, yeah, and up 12. I mean, you know, don't worry about the scale here so much, okay? But it would look something like that, yeah, to get to A from the origin, okay? From the origin, you're going across 5, up 12, 5i plus 12j. Now, to get the size of that, of course, to get the length of this, right, we can use Pythagoras, can't we? Because this would actually create a right-angled triangle, wouldn't it? Okay, here, right? Whereby we know that distance there is 12, okay, because we know how much we're going up, and we know the distance across, of course, is 5, yeah? So with Pythagoras, you square this side, add them, and then whatever that result is, you square root. So I'd want to see that, right? 5 squared plus 12 squared, okay, and then square root. So if I work that out, of course, that's 25, that's 144, so it comes to 169, which comes out exactly then as 13, right? So the size of it, okay, or the magnitude of A is 13. We've worked out the length there, so that's what they're asking there, right? They want the size of it, the magnitude, or the length. Either way of thinking about it there is the same thing, and the length of it is 13, just by using Pythagoras' theorem. Okay, notice the i's and j's have disappeared, because all I'm interested in is the length, right? The i's and j's just tell me what direction to go in. So I know 5i means 5 across, I know 12j means 12 up, all right? But in terms of the distances then, I can use Pythagoras there, and I've got out 13. Part 2 then, okay, we want multiples of B and A combined there. So you can notice we've got 5B take away 2A. So all I've got to do is chuck in B, okay, substitute it in, and then substitute in A as well, okay. So then, if I work that out, times by 5, so I got 35i plus then 65j, and then take away here 10i, take away 24j. Don't forget that minus 2 applies to both terms. Okay, so then if I put the i's together, I get 25i, and then put the j's together, I get 41j. Okay, then it asks, of course, then for the modulus of it, the size of it. So this sort of vector here, okay, again, you'd use Pythagoras. So quite simply, all I've got to do is just appreciate that I need to square this, add them, and square root the result, right? So if I do that, okay, I get 625 here, 1,681 there. Okay, so if I then add them and square root it, I get 2,306. Okay, and square root the answer. Actually, then it doesn't simplify, right? It just stays as 2,306 square rooted, or we could write it as 48.0, right? That's what it is to one decimal place. But I'd leave it as a third, to be honest. I would leave it there. We're happy with our answer. So part 2 then, it says find AB, and hence find the length of AB. Okay, so we want to find the vector AB. When you see it bolded there, right, that's what they're after, the vector AB. Now, a diagram is really helpful here with this, right, when they want AB. So quite simply, I'm going to identify A on my sketch and B, right, relative to the origin, all right? So, relative to the origin there, okay? Now, if I want the vector AB, which is what the question is asking for, okay, then essentially I need to write it like that, right? That's how you write the vector with the going from 2 letters from A to B, with an arrow above. So I want that. Now, to get from A to B, well, I can go from A to O, couldn't I? right, to start with, and then O to B, right? I could do it that way. And you just need to appreciate, right, if you remember, O to A, okay, is just the vector little a from our question, and O to B is my little b, okay? In terms of getting to these positions, getting these points, the vector is A there and B there. If I want to go from A to B, as I said, I've got to go A to O first, and that's the reverse of A, isn't it? To go from A to O, and kind of go in the opposite of A, if I'm going from A to O, so it'll be minus A. And then O to B, well, that would be going along with B. So essentially then I get B minus A. All right? So I can substitute in, and I can put whatever B is. Now B is 7I plus 13J. And I want to take away A then, which is 5I plus 12J. All right? Remember then that the minus then, because we're taking away that bracket, the minus applies to all of it, because I'm taking away the whole thing. And I get, what do I get? Well, 7I take away 5I is 2I. And 13J take away J is just plus J, right? And then when it says in the question then to get the length of AB, okay, now remember, the length of AB is just the size of that vector, the modulus of it, right? Or the magnitude. Lots of different terms there which are synonymous with each other. So the length then, as I said, you use Pythagoras, you square that, and there's 1 there, isn't it? So it's just 1J, so 1 squared, and then square root the answer. And that comes to then square root of 5, and we complete.